All right, now, I'm going to use this second law here, and I'm going to kind of leapfrog off it and give you an interesting example, right? See here I have 2 to the 5 and 2 squared. Well, the secondary example, example 2, what if the powers were also the same? 2 to the 5 divided by 2 to the 5. Now, there's loads of ways you can think about this. We're going to do more than one, but I just want you to think about it through the lens of this index shortcut first, okay? The bases are the same, and I'm dividing, right? So therefore, the power will be, well, I'll minus, won't I? I'll subtract, okay? So I should have 5 minus 5, which of course is 0. Okay? But hold on a second. Hold on. What does that mean? I'll get to your question in a second, right? This is a little bit weird because it doesn't quite fit with what we defined powers to be in the first place, right? Powers are like multiply repeatedly, right? Do it 3 times or 4 times or 5, etc. What does it mean to multiply no times? Okay, Tenda, I think you had your hand up first.
I know what the answer is, but I don't know how to get to that.
Okay, right. Well, why don't you tell us the answer and then we'll explore it together. All right. So this is 1. Okay. Now hold on a second. Let me just say that and make sure you have this all clear. 2 to the power 0. When you multiply by 2, how many times?
0.
No times, right? You end up with 1. Right? Now there's a couple of ways to see this. Number one, we just looked at the index law, right? So that's what we got, right? But just like I went from here to here, I'm going to do the equivalent line again, right? Down here, okay? So I've got 2 to the power of 5, that's going to be my numerator. I've got 5 of these 2's here, okay? You writing this with me? 5 2's. But I've also got 5 2's on the denominator, right? In fact, they're the exact same thing. If you divide something by itself, of course you'll get 1, right? 3 divided by 3, 5 divided by 5, rock melon divided by rock melon, you'll get 1 every time, right? Everything will cancel and you're just left with 1. Okay? Now you can probably see, right? These examples, I've been using 2 as the base every single time, okay? Just because I like powers of 2. But I could have chosen a different base, right? Like suppose I just change these into 3's. Right? If I change those into 3's, what happens on the right-hand side here? That will change into a 3 as well. But apart from that, everything is the same. It's still going to be 5 3's on the top, 5 3's on the bottom. They'll still all cancel, and you'll still get 1. Okay? So now we're starting to see, if you raise 2 to this power, or 3 to this power, or anything to this power, you keep ending up on 1. Question?
If you times 2 or 3 by 0, you end up with 0.
Okay, alright, we'll get to that in a second. I'm so glad you mentioned that. Let's just take this idea first though, what we got from 2, and let's put it into a law, because rather than do this every single time, it's a bit tiresome. And you get the same answer every time, right? So how would I phrase that over here in general terms? Okay. If I have a number, any number you like, right? And I raise it to the power of 0. Every single time, you're going to get 1. Okay? Now let me just convince you of this in another way, because it's always great to see problems from more than one angle. Okay? Just next to where you're doing all of this, I'd like you to draw up a small table with me. Okay? Just a small table. Just do a quick one. Don't worry about doing it with a ruler, because I'd rather have it there quickly rather than beautifully. We can make the point pretty easily. And I'd like you to put 8 rows, 2 columns. 8 rows, 1, 2, 3, 4, 5, 6, 7, 8. And I've got 2 columns here. Okay? I'm just going to illustrate something really quickly. Okay? Excuse me. What I'm going to do is I'm going to compare a number, and I'm going to call the number n for number, with what happens when I raise 2 to that power. 2 to the power of n. And see, I really like 2's, okay? So, for reasons that will become clear in a second, I'm going to leave a few rows blank. I'm going to leave 1, 2, 3, 4 rows blank, and I'm just going to start here. 1, 2, 3. You'll see why in a minute or two, alright? So if n's equal to 1, right, then here I'll have 2 to the power of 1, which of course is 2. I've just got a single 2. Right? On my next row, I'll have 2 squared, right? Which of course is 4. Great, so far, so good. And I can keep my pattern going. Okay, if I had more rows, I could go 16, 32, 64, etc. Okay. Now, we were building this going downwards, right? But can you see, just as there's a pattern going downwards, there is just as much a pattern going upwards, right? Can you see how if I go from here to here, I double? And then here to here, I double, right? So if I went in reverse, I would be halving, wouldn't I? From 8 to 4, I multiply by a half. And then from 4 to 2, I multiply by a half. Okay, follow the pattern with me, right? 3, 2, 1, 0. So this should be 2 to the power of 0. And I just keep on halving. Well, half of 2 is 1. Just like we saw before. Okay? Now, I've left off these 3 rows deliberately. We'll come to them in a minute, but I wonder what you think would go there. Don't shout it out. I want you to have a think, okay? I'll leave them blank for a little while. We'll come back to it. Okay, so a to the power of 0 equals 1, okay? But a question that got raised before was, well, what if we switch this around a little bit? What if instead of having 0 in the index, what if we had it as the base, right? 0 to the power of something, right? Well, excuse me. If you say 0 squared, for instance, 0 squared, by definition that's 0 times 0, which, last I checked, was 0, right? Okay, so I could do 0 cubed, well that's 0 times 0 times 0, which, last I checked, is still 0. Now, this is interesting, right? We saw here, if you raise any number to the power of 0, you'll get 1. So just phrasing it slightly differently, if you take 0 and raise it to any power you like, you'll always end up with 0. Okay? So this is our 4th index law. Okay? Whatever you see, doesn't matter if it's 0 to the power of a million, you're like, I better write out all myriad zeros, just to be sure. No, you don't. This shortcut will save you time.